Eleiko barbell range is built not on reinvention, but on refinement. It's about doing what we've always done, but doing it better. For decades, we have crafted strength equipment that meets the demands of the world's strongest athletes. Today, that legacy continues. The goal was to create a more streamlined bar offering to help guide users towards the right bar for their purposes. And having only 8 bar models with clear intended uses makes it easier to select the right bar. We now have a portfolio with competition bars that are highly specific to competition in the respective sports: weightlifting, powerlifting and para-powerlifting. Their weight is calibrated to the highest degree and the knurling is the sharpest for the best possible grip during the relatively few lifts that occur during competition. And their exact characteristics are dependent on the lifting discipline in question. The training bars are slightly less specific in that the knurling sharpness is toned down a little bit to be easier on the hands and back when performing higher training volumes, while still being similar to the competition characteristics. They also don't have the same calibration requirements, but at Eleiko we still produce them to the same specification as the competition bars, so they are exactly the same in terms of construction and feeling. Most athletes like to train with the same equipment as they compete with, so we're building on that and optimizing for training use. The multi-purpose bars are the least competition specific as they're designed to perform well in all kinds of lifting. While both are generalist bars, the performance bar and hybrid bars have different target uses and thus different characteristics. The performance bar is aimed at general strength training, often rack-based, whereas the hybrid bar is intended for functional fitness or CrossFit type training. Lastly, the technique bar is designed for practicing and refining technique in both weightlifting and powerlifting. Sweden has been at the forefront of steelmaking for hundreds of years, built on exceptional craftsmanship and access to iron ore of remarkable purity. This legacy has cultivated a culture of innovation and world-leading production methods, making Sweden a global leader in clean specialty steels for demanding high-performance applications. This expertise forms the foundation of Eleiko Steel, giving our bars their distinctive combination of strength, flexibility and durability. Today, Sweden's steel industry leads the transition to sustainable steel manufacturing. Eleiko is proud to be part of this evolution, working through strategic partnerships to develop steel solutions with significantly lower environmental footprints, where world-class performance meets responsibility. So clean steel means that the steel has very few impurities or inclusions. You can think of this as a perfectly mixed waffle batter, without bubbles of flour that can burst. Inclusions and impurities act as stress concentrators, leading to the formation of cracks and eventually bar breakage. Purity of production means that the material has significantly smaller inclusions compared to conventional steel, and as a result, the fatigue strength of the steel is increased dramatically. Most metal failures don't happen all at once, they develop over time. And apart from corrosion and knurling wear, steel fatigue is the leading cause of bar failure. While tensile strength is important, fatigue resistance is what defines steel durability in real-world training. That's why clean steel is critical. It's the foundation of durability. It dramatically reduces risk of fatigue failure. The strength of steel begins with its microstructure. Through precisely controlling how you heat and cool down the steel, called quenching and tempering, we can get a martensitic steel that's hard without being brittle. And that's exactly what we want for steel that's used in Eleiko bars. During the quenching and tempering, atoms are arranged into crystals with boundaries between grains, and these grain boundaries act as barriers to deformation. You can kind of think of them as wave breakers. The smaller and more uniform the grains, the stronger the steel. Then we can further strengthen the steel by adding various chemicals and microalloys in different places to limit the movement of dislocations. The high tensile strength and hardness is a result of the specific material composition and heat treatment of Eleiko steel. Tensile strength is the maximum stress a material can withstand while being stretched before it fractures, and is commonly used in the industry to advertise durability of bars. Tensile strength doesn't fully describe how much a bar can take before being permanently deformed. There's more to it than that. Yield strength is the primary property, determining how much load a bar can take before it bends, which tends to happen before the bar breaks. Eleiko bars are known for their whip. They are ductile and have a high yield strength of 196,000 psi and a high tensile strength of 236,000 psi, so they can flex under load without snapping. The whip is mainly determined by the diameter of the bar shaft, as the material composition and distance between weight is roughly the same. A cornerstone in our sustainability process is making products that last. We craft bars that not only perform at the highest level, but endure a lifetime. Every bar in our range is backed by a limited lifetime warranty. This isn't just about longevity, it's about reducing waste by eliminating the need for frequent replacements. Our bars are made of 97% recycled Swedish steel and produced with an 80% lower carbon footprint than the global steel average, verified from cradle to gate. That means from sourcing to production, we have cut emissions by choosing renewable energy for melting and heat treatment, efficient production processes that minimize material waste, and a trusted partnership with Eleiko, a leader in sustainable steel innovation. And with this new generation of bars, the sleeves are also constructed with the same Eleiko steel, further reducing the carbon footprint from previous generations. Just as steel is not steel, chrome is not chrome. DN3 Chrome is Eleiko's proprietary chrome recipe. It consists of a base layer of duplex nickel that makes up 99% of the total depth. This layer is what provides most of the corrosion resistance, and it also improves the adhesion of the top layer, which is the trivalent chrome layer. DN3 Chrome is extremely hard, so it has great wear resistance and thus keeps the knurling sharp for a long time. Altogether, we get great corrosion and wear resistance, and the total thickness is only 25 micrometers, so it doesn't dull the feeling of the knurling. Another important feature is the smooth transition from chrome to bare steel and the strategic placement of that transition to improve the durability of the bar. Hexavalent chrome, which is normally used on barbells, is a process that's both a health hazard and an environmental pollutant. This is due to the chemistry involved, and hexavalent chrome is increasingly restricted in both EU and the US. Trivalent chrome is a more difficult process to control compared to hexavalent, so it's a lot trickier to get right for use on bars. But it's the better choice with regards to the health and environmental risks involved with the hexavalent chrome. Eleiko's DN3 Chrome is also thinner and more durable than many other cheaper chrome variants on the market. This is important, as worn-down knurling, causing a slippery grip, is normally the first reason why you replace a bar. The second reason is that you're starting to see corrosion where the bare steel has been exposed, where the surface treatment is worn off. So having a surface treatment that protects the knurling is key to making bars that last a long time. Eleiko bars come in 4 distinct knurling types, each designed to meet specific needs. The 1.0 standard is a volcano-shaped pattern for all-round high-volume training. This is used on the performance bars, hybrid bars, and technique bars. Then the 1.2 training is a moderately sharp pyramid pattern for the weightlifting training bars. The 1.2 competition is a sharp pyramid pattern for competitive weightlifting, used on the weightlifting competition bars. And then we have 1.5 power, which is a pronounced volcano pattern for maximum grip during powerlifting. So it's used on the IPF competition and training bars, as well as the WPPO competition bar. The numbers 1.2 and so on refers to the distance between the ridges of the knurling tools. That correlates with the distance between peaks on the knurling on the shaft, but it's not exactly the same. And it also doesn't tell you how deep or sharp the knurling is. There are 3 things that determine the aggressiveness of knurling. First, how fast the bar shaft moves through the CNC machine, so how many revolutions the lathe makes in one place before moving the bits along to the next part. And then how hard you squeeze the bits into the shaft. Higher tension creates higher peaks and pointedness. And of course, how sharp the bits are. They have to be replaced after only a few bars because they get worn down by how hard the Eleiko steel is. And a pyramid knurling is the result of high tension and many deep revolutions with sharp tooling. The material is squeezed all the way to form sharp peaks. A volcano knurling is done with moderate tension and rotations, so the steel is not pushed to a full point, and that leaves the center kind of depressed. The balance between grip and comfort is something that's been perfected based on user feedback during our 65 years in business. The theory is simple. Competition bars should have the sharpest knurling to allow the best possible grip during competition, and be adjusted to the lifting discipline, so different for weightlifting and different for powerlifting. Training bars should be similar, but toned down a bit to allow for higher training volumes without tearing up your hands and back. Bars intended for general strength training and high-rep functional fitness training, they have milder knurling, as that's what that group of users prefer. But getting it exactly right in practice, that's where close connections to the community and extensive experience comes in. We offer multiple knurling types because of the different demands in the different use cases. While we're still following the previously mentioned logic that competition bars should have the sharpest knurling, there's more to it. Because of how the sport of powerlifting is performed, the knurling on powerlifting bars benefit from having a deeper volcano knurling but fewer peaks per square area. That tends to provide the best possible grip when performing slow grinding singles in squat, bench and deadlift. And similarly, because of how the bar is moved in weightlifting, the demands are different. Here we benefit from having a not as deep but pyramid-shaped knurling with more peaks per square area. When volcano knurling is used on the multipurpose bars, this makes the 1.0 knurling mild and suitable for high training volumes without tearing up your hands or neck. The optimal rotation system is the distinctive smoothness at the core of the Eleiko feeling. It's responsive, controlled and calibrated for different lifting disciplines. Each barbell sleeve is engineered for specific lifting styles, with a consistent feel from warm-up to max out. Weightlifting bars use drawn cup closed needle roller bearings for responsive rotation in explosive Olympic lifts. They are combined with an inner race of hardened steel that is placed between the needle bearings and the bar shaft, preventing wear on the shaft from the sleeves rotating over time. Together, they have a static load rating of over 4,000 kilos per bearing and distribute load from impacts efficiently. We have two of these in the flange end of the sleeve where the most impact from the drops happen. Bearings are generally not a failure point in bars. However, the amount and placement of them are carefully chosen to maximize durability of both the bearings and the shaft. Needle bearings offer a tighter fit around the bar shaft compared to using just bushings, which reduces noise and minimizes radial play. This improves the user experience and helps with a common problem in CrossFit classes, where noise levels can be dangerously high as dozens of bars are dropped continuously. Powerlifting bars feature self-lubricating, graphite-infused bronze bushings that provide a moderate and controlled rotation regardless of load, which is ideal for the nature of the powerlifting movements, where excessive rotation could cause the bar to wobble and feel unstable. There's a common misconception that the more a bar spins, the better it is. A quality bar shouldn't spin freely when turned by hand unloaded. Optimal sleeve performance is revealed under load, so excessive spin creates instability. Controlled rotation protects your joints and helps align bar movement with your lift. It's about balance, not speed. The optimal rotation also looks different for each lifting discipline. For dynamic weightlifting movements, the ideal rotation is about 180 degrees or half a plate turn. This amount reduces the torque on the wrist and shoulders while avoiding instability and over-rotation that could impact balance. For powerlifting, optimal rotation is far more restrained, ideally under 45 degrees or less than an eighth of a plate turn. This limited movement helps the bar stay centered and stable under heavy loads, reducing drift and minimizing wobble during slow controlled lift. Excessive rotation can compromise balance and reduce the transfer of force in the lift. Hybrid bars use a unique combination of needle bearings and bronze bushings, not found in other multipurpose bars on the market. This combination is ideal for CrossFit or functional fitness type training, as it provides the best of both worlds. You get adaptive sleeve rotation that's smooth for weightlifting movements, but stable enough for heavy powerlifting movements. Much of what defines an Eleiko barbell is what you don't feel, see or hear. When it comes to functional improvements, first we have improved the straightness and concentricity of the bar shafts from F8, IT8 to F6 or IT6, which per ISO 286 means going from a tolerance of 33 micrometers to 13 micrometers. And that's less than the width of a human hair, to give you some reference. In practice, this means that the bar shaft is straighter and rounder than before. And this improves the alignment of rotating parts, like bearings and bushings, so we can have a tighter fit around the bar shaft. This means less noise and less play in the sleeve and a more connected feeling for the lifter. The tolerances that do exist are there for functional reasons. Having no space anywhere would mean that parts can't move freely as intended. And this change also allows the knurling bits to apply pressure more evenly, which improves the consistency of the knurling. The bar shafts are also cut shorter, and a self-locking screw is used to secure the sleeves in place. It's kind of like the system utilized in the Evo dumbbells, which have a proven record of durability. In combination with using new hardened full moon washers instead of half moon washers, This altogether strengthens the construction actually and minimizes axial play. As a result, noise is even further reduced when lifting, and the bars can better withstand being violently re-racked in a vertical bar storage. There are no rattling parts, there's no sleeve movement beyond the optimized rotation. Each component fits exactly, so the bar remains quiet under both speed and heavy load. A patent-pending dual lock system has been introduced, which adds a rubber gasket on top of the outer circlip. This eliminates any play in the end cap while still holding it in place securely, which further reduces noise when lifting. It also effectively seals off the internals of the sleeve and prevents dirt and debris from entering, which could have a negative impact on the rotation of the sleeves. The dustproof seal is a radial sealing made with NBR. That material is commonly used for fluid sealing applications, particularly mineral oils and greases. As it's supposed to keep both dirt and moisture out and grease in, it's a good choice for the dustproof seal. This sits in the flange end of the sleeve. Introduced into Eleiko bars in 2016, the dustproof seals keep sleeves cleaner for longer and ensure greased parts remain optimally lubricated for years, reducing wear on the shaft. With the introduction of the DLS, both ends of the sleeve are now dustproof and almost waterproof. The end caps are redesigned and now sit 0.5 mm recessed in the sleeve end in order to protect it from wear from contact with hard surfaces such as storage units and racks. The new end cap is made of 4301 stainless steel coated with PVD when colored gold or silver, or DLC when colored black. PVD and DLC coated surfaces are between 3 and 9 times harder than the DN3 Chrome, which is already a very hard surface treatment. This makes the end caps extremely resistant to abrasion and corrosion. The end caps feature a new opening mechanism that utilizes a standard 3.5 mm screwdriver for opening, which makes inserting bar sensors and performing maintenance easier than ever before. Patent-pending geometrical changes have been made to the bars in order to improve fatigue resistance. The center of mass is moved in closer to the center of the bar by increasing the bar flange dimension and removing material from the outer end of the sleeves. This redistribution of mass reduces the forces acting on the critical area of the bar just inside the sleeves when the bar is dropped. As the dimensions of the non-certified bars, so the performance and hybrid bars, are not regulated by any federations, we implemented larger changes in geometry for a more significant fatigue tolerance improvement on these bars. These bars benefit the most from the improved fatigue resistance because of how they're used. Higher volumes of use overall in commercial facilities, and in particular more drops with thin plates in CrossFit or functional fitness type training. So to measure fatigue tolerance, bars are dropped loaded with a pair of 10 kilo plates and collars dropped from 2.2 meters onto 30 mm rubber flooring to determine the forces from the impact that are acting on the bar. With these sleeve design changes, those forces are reduced to below the so-called threshold of eternal life. This effectively means that the forces don't get high enough to stress the material to the breaking point, even with repeated use over time. Eleiko's quality assurance begins already before the steel leaves the plant. At Ovako, each batch of steel is inspected using electron microscopy, underwater ultrasonic testing, surface quality scanning, and tested for hardness. Every detail is examined in accordance to ISO standards to guarantee that the structural integrity and consistency is what's expected from Eleiko. A unique serial number tracks each barbell all the way from raw material batch to final product. To ensure that our barbells meet the highest performance and longevity standards, Eleiko's durability testing methodology simulates real-world conditions. We test bars fully assembled under dynamic load conditions that mirror real training and competition. Comprehensive drop testing with varied loads, heights, and surfaces mimicking real-world lifting scenarios. We test the DN3 Chrome for abrasion and wear resistance and use ISO standardized salt spray chamber testing for corrosion resistance. A long-term tipping test is used to simulate years of use and evaluate bearing and bushing durability over time. During the final assembly, each bar goes through a final quality control. It consists of visual inspection to identify cosmetic defects in chrome or steel, bar weight calibration with model-specific tolerances, knurling consistency and depth verification, sleeve rotation torque measurement, radial and axial play verification, and shaft straightness control. One person assembles the bar and another person performs the QC and records all those data points so each bar can be looked up using the serial number. So we wanted to solve two things with the new design. First, it should be clearly visible from a distance that this is an Eleiko bar. This is achieved by the unique end caps and ID rings, the color coding system, and the geometry of the beveled edges on the sleeves. Second, we wanted to make it easy for users to differentiate between the models and quickly and easily find the bar that they're looking for. Normally, you'd have to read on the end cap, which could be tricky depending on how the bars were stored. Now, the model info and weight are clearly visible on the ID ring, regardless of storage position. You're also helped by the color coding system that's inspired by metals, as competition bars use gold, training and performance bars use silver, and hybrid bars use black. Further, powerlifting bars have the thinnest flanges, multi-purpose bars have the widest, and weightlifting bars are in the middle. So a trained eye won't even need to read the ID ring. To improve durability and keep the bars looking new for a longer time, the use of stickers has been eliminated from both the end caps and the bar shaft. Instead, all the information that was previously found on the stickers is now engraved. The new generation of Eleiko bars are even more precise, more durable, and more connected to the lifter's experience than ever before. We care deeply about the details, so lifters don't have to. They just lift and feel the difference.